IIT 2025. A consumer has utility function U equals 4 by 1 squared plus x2 squared. She maximizes utility subject to a budget constraint. The question asks, which solution sets are convex? The key insight: this utility function is convex, not concave. X squared curves upward, not downward. This means the consumer prefers extremes over mixtures. She will always choose a corner solution, spending all her income on just one good. Let's graph option A. P1 equals 2, P2 equals 1, W equals 10. The budget line is 2 by 1 plus x2 equals 10. The two corner points are 5, 0 and 0, 10. At 5, 0, utility is 4 times 25 equals 100. At 0, 10, utility is 100. They are equal. Both corners are optimal. Notice the indifference curves are ellipses that touch the budget line at both corners. Now here is the key question. Is the solution set X convex? X contains 2 points, 5, 0 and 0, 10. For X to be convex, any mixture of these points must also be in X. The midpoint is 2.5, 5. Its utility is only 50, which is less than 100. So the midpoint is not optimal. It is not in X. Therefore X is not convex. Here is the general rule. Compare 4 over P1 squared with 1 over P2 squared. This simplifies to comparing 2P2 with P1. If 2P2 is greater, she buys only good 1 point. Convex. If 2P2 is less, she buys only good 1 point. Convex. If they are equal, both corners are optimal. Two separate points means the set is not convex. Option A. P1 is 2. P2 is 1. 2P2 equals 2 equals P1. It's a tie. Two corner solutions. X is not convex. The statement says not convex. True. Option B. P1 is 6. P2 is 3. 2P2 equals 6 equals P1. Again a tie. 2 points. Not convex. But the statement says convex. False. Option C. P1 is 1. P2 is 1. 2P2 equals 2 which is greater than 1. Only X1 corner is optimal. 1 point is always convex. Statement says not convex. False. Option D. P1 is 4. P2 is 2. 2P2 equals 4 equals P1. Tie again. Not convex. Statement says convex. False. The answer is only option A is true. Whenever 2P2 equals P1, both corners are optimal, and the solution set with two separate points is not convex. Remember, convex utility leads to corner solutions, and tied corners mean a non-convex demand set.